And Adria. I am so excited to be here, and mostly because a little bit about my journey. When I started with adult ed, I started in ESL, but ESL is not my strength. Math is my strength. And so when a math opportunity opened up, I took it. And right away, I realized how lonely it is in adult education. If you're lucky, there's 2 or 3 math teachers on your site. Most sites just have one. And I was lucky enough to have one teacher, but I didn't feel like I was getting what I needed from him. And so I went searching everywhere. I searched, I think I joined a community with CalPro. I took one of their courses. I searched on the internet. I looked on Facebook. There's got to be a group of adult education teachers, right? And so one of my objectives, although it's not written here, is that hopes that as you go through the course, you start building your math community, your people to help you navigate math, because sometimes it's nice to have ideas from others on how they're teaching or ideas they're using and things that are working to get their students to pass. And having that community of other math teachers just feels so very lovely. So hopefully you'll take that opportunity. Our objectives for today, we're going to apply the standards of mathematical practice to instructional routines to look at how it can support engagement in your math classroom. We're going to shift from a teacher-centered approach to a student-driven problem solving. Less of the teacher does and more of the student does. That was one of my big mistakes I made when I first started teaching. And so as I've gone through and learned more, I realized maybe I should stop doing all the problem solving. Maybe the students should do more of it. And last of all, we're going to look at some of the digital tools we can use for learning engagement. And please, please, please feel free to chat at me. You can there's a small enough group of us. You're more than welcome to take your self off mute if you want to, or you can ask in the chat. I'll leave it to you, your comfort level for how you would like to participate. But you will be math students today, so be prepared to do some math. Hopefully this is not new to you, but if it is, the standards of mathematical practice, how long have they been out? It's been a while. I mean, we're now on like the second or third iteration of the standards since they came out. But to me, I was so grateful for them because standards are overwhelming, let's be honest. And there's so many of them. But standards of mathematical practice, they're not about the content. They're about the habits of mind that we want to create in students, starting with number 1, making sense of problems and persevering in solving them. And that is my favorite one because I feel like everything else just kind of falls in place after that, right? If you make sense of the problem and persevere in solving it, then you're going to be better at reasoning abstractly, at constructing viable arguments, and so on and so forth. I want you to think just for a minute about which ones you utilize the most in your classroom and which ones maybe you could focus on improving. And as you go through today's session and through the course this week, I want you to maybe focus on how can I bring more of this to my students? How can I get them to do that? And with that in mind, what are the teacher moves, right? The standards of mathematical practice, they're amazing, but they don't tell us what the teacher should be doing. They tell us what the student should be doing. I found this slide. The source was Robert Q. Berry III. He presented it at a National Council for Teachers of Mathematics conference. So this came directly from his slides. And I love that there are 8 mathematical teaching practices, moves that we as teachers can make to make sure that our students are doing the math and developing those habits of mind that keeps them moving towards the goal of understanding math and being successful at solving problems. So I'd like you to take a minute and please, like I said, come off mute or say something in the chat. about which of these teaching practices you're already using and which one maybe you could integrate more in your future practice. We have a quiet group today. It's because they're all typing away, I'm sure of it. Awesome. I love that. Thank you, Amy. Thank you for your honesty, and I'm excited that this is new for you. It is like a new thing, right? With all these IET courses, all of a sudden these ESL teachers are being called on to support in math, and that's fabulous. Thank you, Beth. Awesome. Thank you, Morena. When I look at these, one of the things I know I always need to work on is posing more purposeful questions, right? It's something, and I'm going to give a little plug because I believe it's CalPro that has a great course on effective questioning strategies, which really help me think about how can I ask better questions to get my students to respond and to try, right? That's what it comes down to. You have to try. I love that. Thank you, everyone, for participating. Okay, so today we're going to do 3 instructional routines, hopefully 3. I tend to talk a lot, so I'm going to try and be brief so we can get through to the 3rd one. So what are instructional routines? They're things we do in the same order every day, right? Maybe you have a getting ready for bed routine. Maybe you have a getting up and getting ready in the morning routine, a work routine. In the classroom, there's routines as well, transitions, right? The best run classrooms, especially those young children, preschool, TK, kindergarten, 1st grade, the very best ones, it's not about the teacher's ability to teach, it's about the teacher's ability to have strong routines that builds transitions. My background, I taught preschool for many, many, many years. We'll just go with that. And the first of the year was always hard because we were teaching that new routine. But as soon as I got them in line, the transitions, they knew where to go and when to go. My job was so easy. And people were always like, oh, how can you handle preschoolers? I'm like, you just train them, right? Once you train them, the job is just fun and easy. One of my routines every night when I go to bed, I bring a cup of water to bed with me. And it's not because I'm going to drink it at night. It's because I know if I don't take my pills in the morning, then I will not take them all day. And today's one of those days. I did not have the water there ready to go. I did not take the pills, and it's been on my mind all day because I've been thinking about routines. And it's interrupting me, right? Like it's interrupting my day because I'm like, oh, I should go take my pills. I should go take pills. What about you guys? Do you have any routines in your work life or in your personal life that help you move through the day more smoothly? No worries. We're glad you're here. Okay, as you guys think about and type your answers for routines that you use, an instructional routine, much like a personal routine, is a repeatable teaching strategy that allows us to switch out the math content, but keep the routine, right? So if you think about, oh, I love that. Thank you, Amy. That way you always have a good breakfast, right? Yes, Beth, my daughter, she's a teenager. She used to lay out the clothes the night before, but now she gets up and then changes her mind. I'm like, what was the point? Teenagers, right? Um, so instructional routines, they're specific, they're structured, and they're predictable. The students know what to expect from the routine. They provide a consistent framework for the lessons. They support persistence, right? And here's why. Because if you did the same instructional routine the day before and the student was successful, the next time you do it, they're going to be like, this one's a little bit harder, but I got it yesterday. I'm going to keep trying. I think I can do it. They foster mathematical discussions and they reduce cognitive load. So you guys have been thinking about your routines in your life, right? Think about how those routines reduce the cognitive load. You don't have to think about what you're going to wear in the morning. You don't have to think about what you're going to eat in the morning. You don't have to think about these things because they're already in your habit stack, right? I do this, 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 this. Likewise in math, if the students know what to expect, then they're not having anxiety or stress over the mechanism for which they're learning the math, and they can focus their cognitive load on the actual math. And also, as we establish these routines, hopefully they promote classroom relationship. Oh, an example of a routine we're going to do 3 of them right now today. So you're going to see 3 examples. And the reason they promote the classroom relationship is because the students start to see that they're all in it together. They're all working towards the math together. They're not alone. And that comes from the idea of the need for change, right? So I am guilty because this is the way I learned. This is the way I thought we were supposed to teach. The I do, we do, you do method. I know you've all been in a math classroom where you've experienced this. The teacher shows how to solve this kind of problem. The teacher works with the class to solve it together. And then the teacher has you practice on your own, whether it be in class or at home for homework. It's focused on processes and procedures, which isn't terrible, right? We do need students to learn processes and procedures, but it's a limited transfer of information. Students are memorizing this one kind of problem, not the skills they need to continue to do more problems. And it's focused on memorization and imitation instead of the thinking skills we need so that they can solve all kinds of problems. So I think the transfer needs to come to be more of you do and less of I and we do. That said, the I do, we do, you do, there's research around the fact that it does work, right? But what is it working to do? So that's just something we want to consider. Is it meeting the goals of getting my student to pass the high stake exams, prepare for college, pass their exams for their certifications, right? Are they going to be able to pass the NCLEX or the pharmacy tech exam? So the goal for the change is that we're going to empower the students to struggle with math. I just said this to my students the other day. I said, they were like, this is hard. And I said, I know, isn't that great? That's what makes it worth it. And, of course, they're like, but because they're adults, they do understand this, that every hard thing that we accomplish is something we look back on and go, I did it. I'm proud of myself because that was hard and I did it. And all the good things in life that we struggle for, it feels so much better at the end. It ends up being like, okay, that was worth the struggle because I'm stronger, I'm better, I'm smarter, I feel more capable, I'm more prepared. So the idea is we want to have our students struggle. We don't want to help them out too easily, right? Oh, you're struggling with this problem? Let's do one together. Let them struggle a little bit. Let them figure it out. Guide them instead of helping them out of the struggle that's so very helpful for them. All right, we're going to start with a notice and wonder. So you guys can use your reactions if you want, or say in the chat if you've ever done a notice and wonder, and if you've ever done a slow reveal graph. Okay, we've got a few saying yes, few saying no. Yeah, I love that, Beth. You know, it took years and centuries for people. I always tell my students that they're mathematicians who were working on a Friday night, and they always laugh at me. They're always like, "Why do the mathematicians work on Friday night?" And I said, "Because they don't have dates. That's why." They were home focusing on getting this right. Awesome. So we have a few people that have had some experience. I love that. So again, you're going to be the students. This is an example of an instructional routine you can use in class. And think about how this framework can be used for other math lessons. Yes, the history teachers, they have dates every day of the week. No Friday night math for them. All right. Take a look at this graph. What do you notice? Awesome. Beth sees some data being compared. Yeah. Some bars don't have data. Absolutely. I noticed that too. We got a couple question marks. I went too far. Come back. There we go. What do you wonder? What questions would you have based on just what you're seeing here? Yeah. What are those missing numbers? Uh, Blue increased, but purple decreased from the first one to the second one, right? But then notice when we got to the third one, things kind of evened out a little bit. Okay, if I asked you to guess the value of the middle blue bar, what do you think it would be? Oh, that's a good question, Morena. Is there a pattern to these? So with the blue bar, how big do you think that is? Yes, cheater. You saw the 52%. Thank you, Beth. Why did you guess over 50%? Yeah, it's longer than the other ones, right? We can kind of compare. It's the longest one there, right? So I see the 43, the 41. It's longer than all of those. 50 is a great guess, right? What about the purple one? 10%? 10%? Less than 22? Yep, absolutely. Alexis, I want to ask you, I'm going to call out on you a little bit. I love that you said 10 or 11, and I want you to tell why you said or 11. Okay, about half of that 22 line. Perfect. All right. Okay, how'd we do on our guesses? Pretty good, right? Some of you did get a preview peek. Sorry about that, but yeah, we did pretty good on our guesses. So now I want you to think, what do you think the relationship is between the blue, the purple, and the gray or pink, depending on which screen you're looking at, those three bars? All guesses are welcome, right? Is there a wrong answer at this point? No, that's the beauty of a notice and wonder, right? Yes, season 5, right? Or maybe the seasons as they went along, right? Okay, Amy's feeling like we're definitely talking about different groups of people, right? Has anyone noticed? Oh, yeah, maybe 3 different years. Could be stocks, yeah, because the gray ones, they kind of stay the same from one group to the next. Did anybody pick up on the fact that group 2 and group 3 do not add up to 100%? Oh, yeah, I just heard that. I don't know, is your name, would you be willing to come off mute for a second and tell me your name? Oh, Frank, thank you, perfect. Okay, thank you, Frank. Frank, so he says, notice that they don't all add up to 100. And I want you to think back now as teachers, take a moment. How would you handle that as a teacher, right? How would you explain that to your students? Would you explain it? Would you let them come to the answer or figure it out on their own? Why 2 of the groups add up to 101, right? It hurts my little perfectionist math teacher brain that they do, right? Why didn't they fix that? CalPro, why didn't you fix that? No, just kidding. All right. Here's some new information. So, how does this new information change what you were thinking about the graph? Probably not thinking stocks anymore, right? Boys, girls, and stocks? Probably not, right? Average, oh, I like that. It's okay, Amy. I love that you're thinking, right? Maybe it is. Oh, wait, no, it isn't. And that's exactly what a notice and wonder does in a slow reveal graph. It's totally okay to be right and wrong because we're all guessing. Nobody here knows except me because I've seen the end. Yeah, thank you, Frank. Yeah, Amy, right away, she said it and then she's like, no, that's not right. But that's okay. It's okay to make a guess and then correct yourself. That's how we learn. When we make a mistake, and we correct ourselves, we remember that mistake for life, don't we? In this week's course, you'll hear some experiences from me about how many years I've been remembering my mistakes. Yeah, maybe none of the above or decline to state. Okay. More information. So what new information did we just learn? And does this change what you're thinking about this graph? And while you're at it, what do you think the title of this graph could be? Interest in majors, yeah. STEM, right? Something to do with STEM. We see that computing, engineering, mathematics. Those who are enrolled in STEM, I love it. You guys are, based on what you know, right? You're making amazing guesses. Oh, a little bit more information. Anybody want to change what they thought based on what they're seeing now? Opinions about abilities. Survey results. All right, here's our title. Um, so how does the title change your thinking about the graph? And what number do you think goes in that purple box? How old were the people we asked? I love this deductive reasoning, right? The fact that we use boys and girls instead of men and women. If it was teenagers, they probably would have said guys instead of boys, right? Awesome. 6-year-olds. At 6 years old, this is what they already thought. Okay, what new questions do you have? Now we have the full graph. You've seen the entire thing. We can see the title, all the information, all the numbers. We see that the vertical axis values. Does this leave you asking more questions? Yeah. Why is the number for engineering so low? Engineering's amazing. And Beth, you bring up a really good point, because you know what? I started as a math major, I switched to physics major. Nobody ever told me that engineering was an option or how much I'd like engineering. My 4th year, I was a super senior. I did 5 years. So my 4th year of college, I discovered engineering, and I took about 10 engineering classes before I graduated with my physics degree. I wish I had graduated from engineering. To this day, I'm like, why didn't they tell me about this? Okay, we're going to watch a quick little video. This is cool. This actually came from AIR, which is CalPro's parent company. Is that right, Adria? I've got that right?
That's a fine way to put it.
Okay.
Yeah.
Associated with CalPro AIR. So I thought this was fun. It was just totally random that I picked this one, and then it happened to be AIR. But let's watch a quick, short little video on the findings. You can hear it okay? Thank you. I'll pause right here. I thought that was interesting. It said, as girls age, their male bias increases. So if you look at the boys, right, there's not a huge change as they go from 6 to 18. They kind of think they're better at everything when they're 6, and they think they're better at everything when they're 18. But notice that bar of like no difference. By the time they get to 18, they can see girls can do math. But look at what happens to girls at 18. That's such a huge drop, right? And I loved that it said this probably isn't what we're doing in the classroom, but it is what's happening at home before they ever get to the classroom. Before they ever enter kindergarten, they already have these preconceived ideas. And then girls just like feed that idea. And thank you, Amy, for your comment, right? My students don't think, oh, gee, I want to go be a neuroscientist ever. But why not? Why not be a neuroscientist? Okay. So we just went through our first standard of mathematical practice. All of you participated in chat. In a live classroom, I would have hoped you would have all spoken out. And we were facilitating discussion. And I might have even introduced a little friction, like, hey, so-and-so, you're saying this, but so-and-so, you're saying this. Like, let's talk about that. Because creating a little bit of friction, a little bit of emotion to the process does create a little bit more of remembering, right? The time when you were like, I was right. I knew I was right, right? Which standard of mathematical practices did you see as we went through this graph? One, two, and three. I love it. Three, one. Yes, absolutely one, right? We did a lot of persevering. It was a lot of slides. Awesome. Two, three, six, and seven. I also added four, which is interesting because we did not physically model, right? But everybody who said, oh, that line is half the length of that line, or that line is longer than that line, that's modeling, right? You are probably visualizing how many, how much 10 is and how many more of that is. And you may not have even realized you were doing that, but that is modeling. And when you think about your high stakes exams, when your students take those exams, they're not going to get their blocks or their tape measures out. Use some visualization or maybe a little bit of paper to write it down and figure it out. But most of modeling does happen mentally. So you guys absolutely saw a lot of them. So the outcomes you're going to see when you do an I notice, I wonder, you're going to see the sense making. The beauty is there's no right or wrong answers until the answers are wrong, right? So it's a low stakes assessment. You're getting everybody to participate because at the beginning, nobody knew what it was about, right? But you're seeing if people can make guesses, if the guesses can make sense, if they can justify their answers. It invites all learners to participate because it's a universal design for learning activity. There is multiple entry points. If one of you had said, I noticed that there are purple bars, I would have said you're right. And wouldn't that be great to be right in math class? It feels good when you can notice something, whether it was mathematical or not, you noticed something. And that's why it's great. It sparks curiosity, right? Your brain's constantly trying to figure out, do I have it right? Do I have it wrong? Oh no, that's wrong. Let me recorrect, right? So our brain is constantly working at like, let me see if I can figure this out and looking to make the connections. Some of the outcomes of slow reveal graphs are sense making, paying attention to detail. So if you've had students where you've worked on graphs and data charts, you know that they suck at this, right? They look at it, they don't even bother reading the title or the axis. They just look and go, I don't know, it's too hard, right? My students all the time, they're like, there were so many of those and I didn't know how to do them. But as they pay attention to the detail step by step, they learn that each piece was an important part of understanding the whole picture. And it follows along with another instructional routine, which is called Stronger and Clear, where each time they communicate, their communication gets stronger and clearer, better and better each time. I feel like I missed something. So let me quick tell you, I Notice I Wonder was developed by Amy Fetter. And originally, I don't think it was for math, but the National Council of Teachers of Mathematics trademarked it as I Notice, I Wonder. And even though they own that phrase, they do consider it to be community property and encourage educators to use it across all curriculums. The slow reveal graph I grabbed was from a website called Slow Reveal Graph. All of the graphs on that website are open access. They're free. They come as a Google Doc that you can put into PowerPoint if that's what you use instead. They are ready to go lessons. You just have to grab it and it's ready to go. You didn't have to build anything. But then when you get better at it, maybe you start building your own slow reveal graphs. Okay. Everybody take a deep breath. I know I'm going a little fast, but I want to make sure we get to our last one because it's my favorite. So the next instructional routine we're going to do is, will this be on the test? This is a test talk which prepares students to take high stakes exams. So where you find this booklet is linked in the course on a Padlet. I think Audrey might put it in there for you as well, or Maria. It was created by a friend of, I don't know, she's not a friend, but an acquaintance of mine, whose name is Erin Liu. She works with adult educators, for adult educators, teaching mathematics. She works for a company that designed curriculum, textbooks for adult educators. She's amazing. Anyway, this book was designed by her, and she updates it every year. So what happens is she, and this is probably the 2024 version, so you could probably find the newer version out there coming up soon. But what she does is throughout the year, she posts new ones on her blog. And then at the end of the year, she puts them all into the book. So then the book is just getting bigger and bigger, but she's not editing the book every time she does a new one. She edits it once a year. And she's also a member of Adult Numeracy Network. So my little plug for them, if you've never heard of them, you should know them if you're teaching math. And a lot of these ideas come off of their website. So we're going to do a math problem. It's going to be fine because we're all math people, right? It'll be fine. So here's the rules. I want you to work independently for a few minutes. I don't want you to share the answers in the chat or with your classmates or come off camera and say, I've got it. I want everyone just to work independently and quietly for a few minutes. The rule is you have to have something written down. If you don't have paper, you can write it down in your brain. I'm okay with that. And I want you to make a guess on the answer. Whether or not you get the answer, I want you to make a best guess. Okay, so we're going to do, let's do 2 minutes. About 15 more seconds. Okay. Now I'm going to have you take off your student hat for just a moment. We'll go back to being teachers for a minute. I want you to think about what skills your students would need to be successful at this problem, or what knowledge they might need to get started. Yeah, hours to minutes. I'm so glad you guys caught that, right? How many times have I assumed I knew what was going on in a word problem and not read it carefully? Converting a fraction to a decimal or using a fraction as a proportion absolutely could be very key to solving this problem. Yeah, proportions. You guys got a lot of the ones I got too. I felt like they would also need to understand the concept of rate, which is a hard one for them. It's funny when I talk to students about like distant rate time problems, and the first time I did it, it was like terrible, right? So then I got better. I'm like, oh, I have to explain to students like how to identify which one's the distance, the rate, and the time. But I live in California where people measure distance and time, right? It's very confusing to students when they have a word problem that says they traveled for 4 hours going 50 miles per hour, and you ask which one's the distance, the rate, and the time, and they're like, yeah, that, they're like, the time is 40 minutes. 40 miles. And so it took a long time for my students to start to understand they need to pick up on those important words of that happen in a rate, and how you know it's a rate and what a rate means and how you could use it as a proportion. So I'm so glad you guys picked up on all of those. Okay, so now go back to being student. No, actually, yeah, go back to being students for a minute. Um, if there was time, I would have you break out into breakout rooms and share your strategy with your classmates. Or if we were in a classroom, I might have students come up to the board and share their strategies. And I wouldn't give them that. Let me try that again. I would not give them an option because I would have been walking around the classroom as they worked on this, looking for different kinds of strategies, because my goal is to get as many different strategies on the board as I can. I don't want students to see one way and think this is the only way. I want them to see 4 different ways to do the same problem. And then maybe I have a different way that nobody thought of, right? Like for me, when I did it, I don't know, I was having a hard time with my mental math, so I finally had to write it down. I wrote 60 minutes plus 60 minutes plus 30 minutes, right? That's my 2.5 hours. And then I had to figure out what to do with that 2/5. And so I decided to go with multiplication, finally got the right answer. So maybe my strategy is different from everyone's, then I would share that. At the end of that, you're going to give the students time to come up with which one made the most sense to them. Have you ever thought you had a strategy and then saw someone else do it and go, oh, that makes so much more sense? I've been tutoring and teaching math since I was a teenager, and I still see new strategies that I'm like, oh, I like that so much more than my strategy. Yes, thank you, Frank, right? We want to give students as many tools as we can. And I know a lot of times my students will say, like, why do I need to know how to do this 2 ways? And I tell them, because you cannot screw a screw with a hammer. You need more tools than one. And just because you can do this one using the screwdriver, maybe you're going to need the hammer tomorrow. So this is the suggested outline for the test talk. This comes directly from Erin Liu's book. So everything I'm sharing about this comes in her book, including that problem. So first thing you do as a teacher, you're going to choose which question you want to work on. Maybe that question relates to something you've been focusing on math, or maybe it's completely left field. Maybe you're ready to introduce rates and you want them to play around with this problem and try it out before you ever introduce the rates or a proportion. You let students know what success looks like. What are the expectations? Do you guys remember what I told you your expectations were? Yeah, you have to write something down. Everybody had to write something down. Everybody had to make a guess, right? Everybody had to try. It wasn't acceptable that somebody just sat there and did nothing. However, during that time when that's happening, there are some teacher moves. And unfortunately, because we didn't do breakout rooms and we didn't do this in person, I couldn't do the teacher moves. But I want you to read these as we go through them and think about what is not on this list. You can ask them to restate it in their own words. So this is for students who are struggling to get started, right? You've given them what success looks like, but maybe they're having a hard time. So we're giving them why don't you restate this? Why don't you explain to me what it's asking? Ask them if they can eliminate any of the choices because they're sure they're wrong. Maybe ask them to draw a picture, right? If you can't figure out the problem worth beans, but you can draw a picture that maybe represents that icicle growing 2/5 of an inch every minute, at least you've made some sense of the problem. Ask them to focus on what they do know. Encourage them to make a best guess and ask them to identify why they're stuck. Like what's getting them stuck? Maybe it's that rate, or maybe they're stuck because they missed that this was minutes and hours, right? So getting them to identify what they're stuck on, what's not there. What does the teacher not do? Exactly. Thank you, Amy. Never at any point did the teacher say, this is how you do it, or start it like this. Here's your first step. The teacher is not doing the math for them. The teacher is supporting the struggle that they're in, helping them feel like they can make progress so that, because that struggle zone, it's a tricky one, right? We don't want them to be so frustrated that they give up. So keeping them in that struggle zone is using these strategies, but never do it for them because then we're taking that struggle away. The teacher also at this point has not given the right answer. So the next step is going to be to have the students share their strategies like we talked about, getting as many different strategies as possible. And at the end of this stage, students should agree on the correct answer. Does anybody want to guess the correct answer or put that out there at this point? 60 inches. You guys got, see, you're all amazing. You're all amazing math students. Go figure. I love it. Okay, so it's not until this point where we've all looked at different strategies, we've seen all the different ways to solve this problem, and then we agree. Now, if I'm a student who did not get the right answer, am I going to feel a little bad that I didn't get the wrong answer? Absolutely. But is that good for me? Absolutely. Because then I'm going to remember this moment for the rest of my life and never make that mistake again. This is where the teacher then shares additional strategies, making sure students have at least one strategy that makes sense to them. This could take a hot minute. And then finally, to encourage note-taking, giving students time to internalize their preferred strategy. The recommendation for this test talk as an instructional strategy is 30 minutes. I want you to think about how that would work in a classroom. I don't know how long you guys teach for. My class was always like 2.5, 3 hours, right? So if I were to do this for the first 30 minutes, and the first time it's going to take longer because the first time they try something new, it does. But then as we go along, they get better at the strategy. And then it no longer becomes about that routine. It becomes about learning the math. So some of the benefits. They're making sense. They're persevering, right? We're not letting anybody just sit there and stare at the paper. Everybody had to do something. We're asking them to construct viable arguments, and we're asking them to critique the reasoning of others. Oh, did Joey's way make sense to me? If it did, great. If it didn't, it's fine, right? Flexible and creative thinking. There's many ways into this problem. There wasn't just one way. Getting them in that struggle zone and keeping them in there, because that's where they're going to be productive. And then it's about developing transferable strategies. This is not about them knowing that an icicle is 60 inches after 2.5 hours. Yes, they're learning how to use the tools in their toolbox. This problem is about, can I use what I learned here, like missing that part about the minutes and the hours, and transfer that to the next problem I have where the units don't match up? All right, we're down to our last one, and this is my very favorite. Has anybody heard of Desmos classroom activities? Awesome, Frank. Awesome, Beth has. Yay, we've got 3 who are experienced in it. Okay, Desmos has changed their name. They're now Amplify. I don't know if Amplify bought them out or if they just changed their name. Along with that, they went from being completely free to a freemium, right? So what we're doing today is completely free. You can take this activity back to your classroom or any of the other free activities. There's no, limit on that. They do have some things that they want you to pay for now, but along with that, what they brought in is with each of their activities, they now have worksheets, paper that goes along with it, which is kind of cool. So if the students aren't on a computer, right, they can still participate on paper. So we've got a link in the chat, and I'm going to have you jump in there and click on that link. It is going to open you to a new window in the internet. If you're on your phone and you can grab a computer, this will be better. If you're on your phone and it works, great. If you're on your phone and it doesn't work, then just follow along with me. And I do want you to be able to go back and forth between the screens because I'm going to be showing you some teacher moves and like what the teacher would see. So you're going to be students, but you're also going to see the teacher's side of things. So if you are successful, you're going to come up with this page that's asking you to sketch a graph. And when you get there, you don't have to create an account or anything. You can just sign in without or sign up without logging in, I think is what it says. Hey, I have 10 people. You guys are super fast getting in there. 10 of you. I think we might just be missing 1 or 2. For those of you who did make it successfully to the page, I want you to draw a distance versus time graph to represent a turtle's journey across the sand. So quick couple of tools. Right now you're on the pencil, which allows you to draw freely. If you are, no worries. Thank you for being here. If you are like me and your little brain hurts from free drawing, you can use straight lines here. If you want to change the color or the size of your pen, you can. It's not necessary. And lastly, if you do not like your drawing or you've done it and want to start a new one, you can click on the X. So the idea is for you to just draw a graph of the turtles crossing. So I'm going to do something like this. and then you hit play. And watch what the turtle does. That's all we're doing. We're just playing around with it. So give it a couple tries, do it once or twice if you want. My turtle kind of hopped. I don't know when turtles started hopping, but I might want to think about why did my line make him do all that hopping? Oh, I love this one. So I'm going to ask you now to come back to the Zoom shared screen because I want you to see a couple of things that are happening on my side. Can you guys see that screen, the teacher screen?
Yes.
Thank you, Frank. Okay. So a couple cool things on my end. I've decided I don't want to embarrass any of my students who are struggling a little bit with math. And so I have anonymized. So I can see that I have all but 2 students have logged in and gotten started on the first one. And I have 2 that are kind of still working on that first one. They haven't tried it yet, right? Right now I have this on paste, so nobody can go to the next screen. As a teacher, you can choose to pace, which is great the first time you do these activities, or if there's something specific you want to focus on, it's great to be able to pace the student to what you want them to be doing. Over here, I am looking at the teacher summary. I can't, the summary. I can go over here to the teacher where now I can see everybody's graphs, right? And maybe I want to share one. So I'm going to click on this one because I think this one's so very interesting. And I'm going to present it as a snapshot. So if you were a student, if you're looking at your student screen when you went back, you'd be seeing this snapshot. Okay. I love this one. Does the person who did this one want to tell me what happened with their 4 lines? Yeah.
Yeah, that was mine. And I don't know, I tried to erase one I kept deleting and doing it again. I was just going crazy, but I was watching the turtles race. But
Right. How many
yeah.
turtles did you have, Amy?
Um, well, I don't know in the end. Right now you can see I did one, I erased like a squiggly line and then it erased part of the line, so I
Down there,
drew
yeah.
over it. So I think a turtle disappears, but if you start it, there's like a lot in one, I don't know, 1, 2, 3, 4. Anyway, it was fun.
Yeah, thank you. I love that. Okay. So I can see everybody's, I can say, oh, I really want to focus on Eugenia's or Eugenia's, right? And I can, as the teacher, then show a specific one. A couple of other things. I can look at the student view. So if I want to see what the students are seeing, I can do that here. Oh, and I forgot to tell you back here on actually it's on all the screens. Down here at the bottom, we have teacher moves. Who doesn't love to be told, what am I doing with this screen, right? So that's ready to go. It tells you exactly what you can be doing while the students are working, right? I love this one down here at the bottom under Connect. I don't know if you guys can see it because it's at the bottom, but it says, identify a student whose brilliance has not been yet recently recognized and celebrate their thinking publicly by choosing their graph and discussing their ideas. What's so cool about this? Was there any right or wrong answers yet? No, everybody could come into this, that universal design for learning. It did not matter your level. All you had to know was how to draw a line on the computer. Everybody could enter. All right. If I wanted to at this point, I could then click here to pace you guys to the next one, or I could just turn off pacing and let you guys have at it. Okay? So I'm gonna go ahead and turn off pacing. I'm gonna let you have about, what time are we at? I'm gonna give you about 5 minutes to play around with it, maybe 7. If you have questions or concerns or you get stuck on something, let me know. Otherwise, I'm gonna be participating with you as if I was your teacher. So, and just so you're understanding, what you're doing is at the top, you're clicking next activity, right? You're just gonna go to the next screen, and play around with all of them. Thank you, Sylvina. Thank you for being here. Speak. Okay. I am going to now do something. One of the other tools you can do is as students are working, maybe you want everybody to suddenly be on the same page you are. So that option for me on my screen is called Sync to Me. So when I clicked on that, now I have everybody moving to the last screen, right? It automatically moves you to mine, not the one you were on. And I'm seeing how well you understood the lesson, right? I had one student who was like, I agree. I had such a hard time on some of these slides. I'm still working on some of them, right? But guess what? I'm still working on them. I haven't given up. Like, I think I can get him across that without hitting the snakes, right? I'm still trying to get him across. If you didn't see which screen I'm talking about, that is this one, where you're supposed to try and get him to go across from the grass to the water without hitting the snake. Mine hits a snake every dang stinking time. I've gotten pretty far, but then, yeah, so. So this is an example of a Desmos classroom activity. Ideally, this would have lasted 30 to 45 minutes instead of just 10 to 15 like we did, but I wanted you guys just to have a little flavor of what these look like. Do I have any questions or comments? You guys are making my job easy. Amy, did you want to say something? I don't know why it suddenly just lit up on your screen because you didn't unmute.
Yeah, no,
Hopefully-
I'm no questions. But that was cool.
Good. I'm glad you enjoyed it. Yeah, how can we help the students understand the math on this game? What was the math? What math were we trying to get them to understand? Distance versus time graphs, right? Man, that is like the bread and butter of a physics classroom. They could see this on a science HiSET or GED test, right? The same they could a math test. What else? Linear equations, nonlinear equations, piecewise functions. There's so many applications, right? There's so many jumping off points. Yes, relative locations, functions versus non-functions. Did anybody see when the turtle split into two? That happened on screen 6. So on screen 6, when you press play, at one point he breaks into 2 turtles and then it comes back to be 1 turtle. Why did that happen? I mean, that doesn't happen in real life, right? 1 turtle doesn't become 2 turtles. It's more like 2 becomes 3. I guess 2 becomes more like hundreds, right? I like that, Frank. It's double from another dimension, took its place and sent it back in time. Little matrix, right? Mathematically, I'm going to tell my students it's because it's not a function, right? As soon as you have 2 y values for only 1 x value, it becomes not a function and now it's some kind of relationship. Absolutely. So there's a lot of jumping off points. The great thing about all of these activities, they're all customizable. So no, that's not true. Many of them are customizable. Now that they have this whole paid feature, some of them you cannot change. But the beauty of this is, let's say I just didn't even want to talk about slide 6, right? I could have taken it out. Likewise, you can duplicate slides and change them. You can add your own slides. This one that happens at the end, asking you like how you felt about it, that they have ones that are starters too, like, you know, how are you feeling today? And it's just an XY axis, right? And it's like sleepy or awake, tired, excited, bored, right? And students can find which one of the 4 quadrants they want to put their dot in. Lots of fun ways to get students to interact without feeling like they failed, right? To get them to persevere and to try. I did give feedback and I was trying to look and see on my screen. I think because I need to turn off the pacing. Let me try that really quick. So if I turn off the sync to me, I did go in and give feedback to every single learner on this screen. I don't know, some of them, oh, maybe the green means they haven't read them yet. So hopefully you saw that I gave feedback. Why is feedback so great, right? It's in the moment. I am looking at what you're doing and I am asking probative questions. I'm asking you to think about what's happening. I'm giving you some like, hey, you're on the right track. You've got this idea. So this one, let's pull this one up. So if you come back to my screen, you'll see a snapshot of Abu al, oh, I'm going to mess that up, Wapawuzjani, which is a mathematician somewhere in the world. All those names were mathematicians, I think I told you, and I love that there's women on the list, right? Help fight against those 6-year-olds thinking girls can't do math. So This one, I gave the students some feedback. Come on, let's go back. I don't know what happened to the feedback. I swear. Anyway, I did give some feedback. Maybe it just didn't go through. Maybe the student already saw it. But I really want to know, like, what did the student see? Right? When you have two lines crossing, what's happening to that turtle? And I asked the student, at what time did those turtles cross? Because now we're talking about system of equations, right? When two lines cross, what does that mean? Lots and lots and lots of interesting things. A couple things I'll tell you about Desmos. We'll come back to my slideshow. So I am going to have you guys leave this and come back to the slideshow. You can pause the activity as a teacher too, if you need them to stop looking and paying attention. And like I said, there's also with each of these, there's now paper stuff. And I was noticing this one also had like homework you can assign, right? So you played around this in class, we did it together, we talked about it, and then you can assign as a homework assignment to go home and work on it some more. So the benefits of activities like these, they are formative assessment, right? I was just looking to see who kind of got the idea, who was struggling. And a formative assessment is so helpful because I can stop and help right then and there. And the fact that it's online and I can go in and give comments to individual students makes them not embarrassed if they got it wrong, right? Or I can celebrate the ones that were unique or interesting. Hopefully you all felt engaged in the activity, right? Felt like, hey, this is kind of fun. I'm making this turtle cross the road. Lots of their activities are like that, just highly engaging, kind of fun. You're getting the real-time feedback, both from the program and the teacher. And we didn't do any, I don't know, were there screens where you had to give answers? Like you had to type in answers? When you get to those screens in the Desmos activities, thank you, Amy. Your classmates can sometimes see those, and that's helpful because then you see what your other classmates are thinking. And again, this is a very individualized opportunity for you to go, oh, maybe I'm not on the right path, or maybe I need to rethink what I'm thinking. It can be run synchronous like we did here today, or asynchronous. I am going to put this activity on, or I think it's already on the Moodle course. So you can go back in and play with it, or you can take it as the teacher and run it. It can be teacher paced like we did at the beginning. I'm like, I want everybody just on this screen, or everybody can do the first two screens, or you can just let the students have at it. It's a great warm-up activity once they're used to the instructional routine and they're ready to go on Monday. Does anybody want to share some of, I know, because we've had several people who have used these in their classroom, any of the outcomes they've seen? Once and twice. All right, hopefully, oh good, we've got the graphing the absolute value activity. Thank you for sharing that. I like the land the plane one. Also recently I got introduced to the marble slide ones. Oh, I had all kinds of fun with those. Yeah, those vertical shifts, horizontal shifts. Thank you, Beth. Just so you know, the Desmos activity website is linked on the Padlet. Additionally, there is a couple documents linked where Adult Numeracy Network They had these Des Mondays where a bunch of educators just got together and played around. And part of that was building a list of activities that you could use. Now that Desmos has become Amplify, I do believe those activities still exist. I played around with some of them, they were still there. However, there may be some restrictions on what you can customize or not customize. It used to be that you could build, thank you, CalPro. You could build your own activities from scratch. And I do believe that that is still the case, that you can build an activity from scratch. They have flashcards, which is great for our IET users, especially where you do a matching game. They have, what else? I'm trying to remember. I'm going to let it go because I want to wrap up on time. Anyway, this and all instructional routines that we've looked at today and are looked at in the course, as well as many, many, many more, can be found on ANN's website under instructional routines. I've put a couple here that I really like. I love 3-act math. If you haven't done 3-act math, you should definitely look it up. It's gotten to a point where they're a little old, but Estimation 180, he does a couple of great 3-act maths. Exit tickets, number dot fraction talks, those all come from Joe Bowler, I believe. Which one doesn't belong? It's a great startup instructional routine, right? Again, because the answers are all right. They all don't belong. You just have to tell me why. Would you rather, right? Would you rather have a 10% off coupon or a $10 off coupon? At what point doesn't it matter, right? Wrong answers only, that's a really interesting routine where the students have to give the wrong answers, right? What's the point of giving wrong answers? Because when your brain makes the mistake and corrects it, it remembers better. All kinds of fun things. Has anybody used any of these or any others they would like to share? Okay, so the key takeaways from today's presentation. Thank you. Different strategies to solving problem like math talks. Yes, absolutely. Think, pair, share. Absolutely. Those are all great instructional routines because an exit ticket or a think, pair, share can be used with any kind of math. It's not the instructional routine creates the framework to then teach any kind of math you need to teach. So instructional routines build the confidence, reduce that cognitive load of like, what are we doing? They know what they're doing. They just focus on the math and they promote deeper learning. Sense-making strategies help students develop problem-solving skills, and student-centered math instruction fosters perseverance, critical thinking, and long-term success. Instead of them waiting to be fed, they are going to the buffet and partaking of it themselves. So what's next? The Moodle course is open. I believe it was opened on Friday. Is that true? Or is it? Okay. The Moodle course is open. You have a week through Sunday to dive in, introduce yourself if you haven't already, and complete the 4 sections. Each of them come with a couple of videos and then a discussion board or an assignment. One of those is a Padlet. So if you've never used Padlet before, it's not a problem. It's not very hard to use. But in order to get credit for completing that assignment, you do have to have a name on your post. So to get your name on your post, either you have a Padlet account and you're logged into it, or you put it in the comment or in the post itself. So that's my one quick reminder. Please, 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 when you do the Padlet assignment, just make sure that your name gets attached to it so I can give you credit for it. We did it.
We did it. I had to find my mute button so I could come in and celebrate with you. Thank you so much, Christina. And thanks, as well for just pointing everyone back to that Moodle and just making sure that everyone knows, yes, the course is open. I think you had access to it as of Friday, perhaps, but it's officially open today, and all of those activities will be available to you from today through next Sunday, by which point you'll need to complete all of your assignments. The course will stay open, I'll say now, and we'll email about this as well later, but the course will remain available to you for another couple of weeks after that course closing date, just so that you have the opportunity to go back in and grab any resources or pull your own, discussion posts or anything like that that you might want. But just so that you know, again, the dates for working in the course will be today through Sunday. So thanks again to Christina for your excellent leadership and facilitation today and throughout the week ahead. And thanks to all of our participants for attending today. It's been a pleasure to have you. Thanks for being active. And we look forward to continuing to engage with you over these next several days ahead. Thanks all.
Absolutely.
are
And
you
then
able
really
to
quick, I
see-
did see that the Padlet wasn't working for someone. I will go in and make sure that all my settings are correct, so everyone will be able to access it.